Oh, me? I'm just practicing levitating this tree. They've always said practice makes perfect, so why not? Let's practice to solidify the concept of converting decimal to binary. I'm going to throw 3, maybe 4 problems at you, and they'll be very simple, just a number, and I'll say convert that to decimal. No, I'll say convert that to binary, and then I'll work through it with you, okay? So here we go. I'll throw 4 numbers at you. How about we do 50, let's do 100, and let's get into challenge territory. 500 and 2,000. Sound good? I know. Some of you are like, wait a sec. You didn't tell us how to do those. Oh, you'll figure it out. I know. So pause right now. See if you can do it. Okay, at least the first 2. If you're not an adventurous one that likes to go a little bit beyond, but I think you can figure it out if you just apply yourself. Pause, go work through these, and then come back. Here's what I want. I want you to give me the binary equivalent of what those decimal numbers are, and then we'll review it together. You ready? Pause. Right now. Right. Click the button. Okay, I'm going to assume that you did. Okay, first thing that we've got to do is write out our binary chart. And you remember, with our 8 bits, we've got 1, 2, 4, 8, 16, 32, 64, 128. If you forget that chart, you can regenerate it just by starting by 1 and multiplying by 2 until you reach 128. This is 8-bit numbers. And if you only have 8 bits, you can only get to a number that goes up from 0 to 255, which makes us look at both of those and go, doesn't it? So let's look at number 1, 50. How would we figure that out? Okay, well, I'd go down here to my chart and I'd say, okay, for 50, can't subtract 128, no 64s, 32. Okay, so 50 minus 32, that would equals 5, 4. Oh, and by the way, if you are taking a certification exam, they tend not to give you a calculator on those exams just because they're mean, right? So we've got 132 on there. We've got 116, so 16, that'd be 2. No, 1, 0, right? So that would give us our 2 back to 0. So the binary equivalent of 50 would be 0011 0010. Good? How'd you do? Feeling good? Good. All right, let's do 100. 100. Here, let me switch my pen colors. We'll go black. So 100, same thing. Nope. Yep. So minus 64. That'd be 0, 9. That'd be 6, 3. 36. Yep. 32. That'd be 4. So no. Yes, no, right? Because that would zero us out. So binary equivalent of 100 is 011001000. Feeling pretty good, right? How'd you do on 500? 500? Anyone get it? Come on. You feel it. Let's try it together. Here we go. So first thing that I would know is I know that I can only get numbers up to 255 with 8 bits. So what does that tell you? Okay, use a little intuition and go, well, if we can't do it with 8 bits, can we do it with 9 bits? So if we multiply 128 by 2, that gives us 256. And just for grins, I'll multiply 256 by 2, and that gives us 512. Okay, that's more than 500, so I can stop there. I know I've passed it. So my first one doesn't go right there. It goes right here. I need 9 bits to get the number 500. So same story from there on out. That'd be 5, 4, 10, 9, 4, 9 minus 5 is 4, 4 minus 2 is 2, 244. Okay, so my next one goes right there at 128. Am I doing that right? Sometimes I do this so fast, I might throw myself off. All right, so that'd be 6, that'd be 2, 13. Oh, wait, I don't have to do that. So 3 minus 2, that'd be 1. That'd be 2 minus 1, 116. Okay, so 1 right there. Man, this is bigger than I thought it'd be. All right, so 2, 0, 5, 52. Okay, so 32. I can do that. That's 20. So 16. I'm running out of room. That'd be 4. Thankfully, I've reached the end. There's my 4, 0, 0. So the binary equivalent of 500 is 1, 1, 1, 1, 0, 1, 0, 0. It's 9 bits, right? That's 4, 5, 6, 7. Oh, what did I do wrong? Hang on. 1, 2, 3, 4, 5. Whoop, there you go. So that's the binary equivalent of the number 500. Okay, so how about this one? Now, using that same logic, you would go, okay, well, let's go a little step further. 512 times 2, that'd be 1,024, right? And if we multiply that by 2, that'd be 2,048. That's, again, past what we needed. So let me just, hang on, I got to change paint colors. Here we go. I'm going green. Nope, we can't subtract that, but we can subtract that. So minus 1,024 equals 2, 1, 10, 9, 10, 9. That'd be 6, 7, 9, 0. 976. Okay, so next one up would be 512, 512. Sorry if my stacking my binary is doing it. I'd use the colors. Colors distinguish. Okay, so 512, 976. That'd be 4, 6, 4, right? 464, 256. So our next one that we subtract, that'd be 5. 14 minus 6 is 8. 0, 2. 208. Okay, 128, 128. And by the way, if you get to here and it's anything bigger than 255, you know you went wrong somewhere. So there's our 128 minus, that'd be 0, 80, right? So then that'd be 64 minus 64, that'd be 7, 16, right? Woohoo! That makes it easy because I know, oh, where am I at? I'm cutting into my numbers here. 0, 1, 0, 0, 0, 0, right? Because I sorry, it's just turning a big blob at this point. 2,000 in binary is 1, 1, 1, 1, 1, 0, 1, 0, 0, 0, 0, right? Am I seeing that right? I sure hope so. How many bits is that? That'd be 5, 6, 7, 8, 9, 10, 11, right? 11 bits? Yeah, because this is 8 bits, 9 bits, 10 bits, 11 bits. Right, good. How did you guys do? If you need more help with that, please, let me show you a quick, easy way you can verify your work. I'm going to assume you're using Windows 10. If not, then you just need to use Google. But if you go to Windows 10 and open the calculator, it's included in Windows by default, change the view over to Programmer, and you can verify your work simply by typing in whatever decimal number you want. And you can see right there, it's going to generate the binary equivalent, right? So 90 decimal in binary, that's it. Escape to clear it out. I'll do 800 as a binary number. That's it. Now, the Windows calculator takes the binary in series of 4 bits. So, for instance, when we went 800, it technically only takes 10 bits to do it, but it will add 2 leading zeros onto that just because it allocated the next series of 4 bits. You've now practiced to solidify the concept of converting decimal to binary, and I would please encourage you to practice some more. Practice until you're like, I've got this cold. I can do it, and I can do it fast. I hope this has been informative for you, and I'd like to thank you for viewing.